Well, greetings on this not too warm a day, but it's sunny and the cloud from this morning is going. And I spent most of the morning trying to figure out mathematics. I wasn't very good at it at school. Disliked the subject intensely. But it wasn't until I left school and started work that I suddenly realized the beauty of mathematics. And I used it a lot when I was on the board. Very few calculators in those days. Everything was done longhand, and I suddenly found I liked it. And when computers came along, and I was freelance at the time, and I was working on Birmingham Airport, and I came up against an Apple II, and the engineers were playing around with this new toy, and one of them showed me a spreadsheet. I can't remember the name of it now, but it's the one that started everything. It was the first computer spreadsheet. And I suddenly realized what it could do. And that changed everything. Excel came out and changed hands a couple of times. Microsoft got hold of it, and then it's what it is now. And then Apple made their own. And because I'm mostly Apple based, then I use numbers mostly. Unfortunately, the two just sort of don't ring together very well. They have different ways of looking at mathematics, and I learned the Apple way, and it works well for me. And then suddenly, computers and CAD came in, and the spreadsheet was linked into the CAD program, and then that helped enormously. But there was no real interface there. It was part of it, but it wasn't, if you know what I mean. And then all of a sudden, graphical programming interface came in, and that changed everything, because all of a sudden, all these complex formulas and mathematical sequences suddenly became little tiny blocks, and you dragged them out and put them onto the screen. And it was a sheet within the program, the project you were working on. So that sheet knew parameters. You just had to drag those parameters in and put them into the program or the little block. And you string them all up and you put more calculations in. And all of a sudden, you've got the most incredible spaghetti of calculations going on. And it's wonderful. And I don't think we've even begun to start looking at the real superpower of doing all this in graphical programming interface. I quite like Vectorworks. Vectorworks has got Marionette, and Marionette is very pleasant to work with. And so that's the one that I learned. And I'm very pleased with it. But going back onto old days when there was ways of working, when I was on the board, everything was done by longhand, and I had log tables. And my father taught me a little poem: some people have curly brown hair till partly bald. The modern teaching now is SOHCAHTOA. I have no reason to understand why they changed it, but there you go. And then I found two really, really good books. And when I was teaching down at Gloucester, and then further on when I was teaching at Birmingham City University, I found two fabulous books. The first one, and I hope it comes out well, but it is Construction Mathematics by Surinder Virdi and Roy Baker. I've got an older version. I know that there are newer versions of this out, but the maths doesn't change. All they've done is updated it and made sure that it is correct, and perhaps put a few more nice pictures in and everything else. But Construction Mathematics is the one that I really do like. And then there is this one, and it's Surveying for Construction with William Irvine and Findlay McCallum. And I've got a 5th edition, and as you can see, it's well used. I've got sticky bits in showing me where I wanted information from. And it works extremely well. It's a fabulous book. So what I've decided to do is to try and put all this into the new book, into Mitchell's, and it's obviously in the advanced section. And I'm starting to flesh out what I want to try and do. And I'm quite keen that we keep alive this idea that we have to do it longhand every now and again. It keeps the brain fresh. And to be honest, if you're on site, and your computer doesn't work, there's no telephone, there's no Wi-Fi or whatever, you've just got to go back to pencil and paper. I've said it many times in different areas about detailing that pencil is the universal language. Well, so is mathematics. So you just pick up the paper and you start doing the calculations, and the guy will suddenly turn around and say, yes, 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 and then you'll understand it because the language is mathematics. And I quite like this idea of going back and looking at old ways of working and making sure that the brain is functioning properly. So I've done this, I've fleshed it out, and what you're going to see in the sheet below you, this little Substack article, is my ideas that I'm pulling together to try and put it into the book about the use of pencil and paper, graphical programming, spreadsheets, and your phone as well. Don't forget that. I've got an iPhone, and it's slightly different to Android or Samsung or any other phone on the marketplace. But it works for me, and I just had to learn it. Now, there are absolutely loads of different types of tutorials on YouTube to show you how your particular phone works, and they all work in a slightly different way. Some want you to put in the tan first and then the number, but Apple doesn't. It wants you to put the number and then tell it's a tan or a sine or a cosine. So work with it. But above all, play with mathematics and start to learn how to use it with the new future stuff that I'm writing, because this is the last chapter in the book is the future. And the future is mathematics. It has to be. How it works, why it works, and how programs will take those calculations and take direct from the project itself, the drawing, the information that is required, and then do the calculations and then maybe warn you or do things, even alter the drawing to make it work. So big thing, keep up with it and work well with it. Enjoy. I hope you're well. Toodaloo.